I'm recording this mainly for the B group, but you guys are going to help me out, okay? So when you're given this, what we call a parent function, and you need to move it left or right, that has to do with the x. And think of the x-axis as being going this way. Whoop, I don't know why it's doing that. Think of the x-axis as being your, still doing it. Maybe if I put my pen down, it'll activate. Oh, come on guys, what's going on? Try one more time, the highlighter. Maybe blue. There we go. So when it's left or right, you mess with the x, okay? So when it says 4 to the right, it means we're going to start, it says an equation, so you have to write y equals or you'll get points taken off. Well, now it's activated, that's the word. I don't know what's going on. There, isn't that weird? Like, I don't know. It's not a very smart board. So you're going to mess with the x for left and right. So all I did is remove that blue thing. I'm going to put stuff in for it. To move it 4 to the right, you actually do the opposite of what you would think you would do. Like 4 to the right, Leah, I think I should add 4, right? But left and right, it's the opposite of what you would think. So if they say on your test, 3 left, you're going to go x plus 3. Does that make sense? Now when it says 6 up, that you tap on, because it's the y's that equal, and you're going to move it 6 up. So I just add 6 to my y values. So the up and down is tacked on. The left and right is in with the x. So I'm going to have you guys write one of those. How about if it goes 5 left and let's say 4 up? Just write that real quick. If all it is a left, right, up, down movement. And it's the same parent function, which is the x squared. So if all you have to do is write an equation that moves it 5 left, what will you put in for the x to move it 5 to the left, Connor? X plus 5. And to move it 4 up, add 4. All right, so you guys got that down, right? Does that make sense, Leah? All right, now how do we make it from, and last week in B group, you guys weren't with me hardly at all, but this A group was, and I was showing them everything on Desmos calculator, and I kept throwing a negative in front, and you remember it flipped it over, right? So when it says it reflects over the x-axis, you immediately go like that. Okay, putting a negative will reflect it. If you put a number after the negative, like a 2, it'll do a vertical stretch. Make it, it's like if I pull on you 2 times as high, right? You'll stretch and get thinner. And if I squish you down to like a half, but the negative flips it. This says nothing about like a vertical stretch though, so don't put a number down. All it says is that it's moving it 7 down, so don't mess in there with the x. You could put x minus 0 if you want, Leah, but you're not going to move left or right, so don't put anything in here, okay? But it says 7 down, so then what? Subtract 7. Exactly. Do we get why there's nothing in here? Right, because that would move it left or right. All right, let's go to the next page and see what we have here. Now we have a similar one. Except now we're dealing with that absolute value function, and we graphed that a ton last week, but there's the parent function for it. It says to describe the transformation. So you have to tell me what this, and this does. So there's 3 points for that one. For letter B, there's going to be 1, 2, 3, 4 points. You have to tell me what every number is that got tacked on to the parent function. So we're going to start. The 4 out front. Shay, what do you think that does? It won't flip it because it's not negative. But what does that number out front do to it? Yes, you can't hear her. She said the stretching. Yes, it's a vertical stretch. What that means is the y values will be 4 times as big. So it's going to, instead of being at 1, 1, it's going to be at 1, 4, and it's really going to pull it and stretch it out and make it skinny. Okay, Leah? It's not going to flip it. Okay, so no reflection over the x-axis. What is the -1 in with the x going to do to it? It's going to move it which direction? Left or right? Right. Yeah, it's the opposite of what you think. See, B group, this A group's on fire, but we've met a bunch, right? So it's going to move right 1. So if I were to take this stretched out thing, right, it's going to move to the right 1. But there's also a +3 on there. So what's it going to do? Up 3. Yep. And that would be move 3 up. Those are the 3 things that are tacked on there. And those are the 3 things it'll do to the graph of the absolute value function. Now letter B, there's going to be 4 things you're going to write. So you'll get 4 points. I always say just write them in order, left to right. Okay? So the first thing to deal with is the negative. What are you going to write for that? Yes, thank you for not saying flip. It does flip it visually, but you're supposed to write x-axis reflection, or if you didn't hear him, he said reflect over the x-axis. That flips it over. It takes all the y values and it makes them the opposite of where they were, because that's what the negative does, opposite. So x-axis reflection. What do you think about that, Leah? You good? So negative out front. Number 2. The half, what does that do to it? Well, it squishes it down to a half, right? It compresses it. So we call it a vertical, did they say to write compression? I don't teach this class, but does that, okay, so I don't know if you have to write vertical compression, but I will. It makes everything half the height it used to be, so that right here, instead of being there, it's going to be half of that. So you can see it, it's going to widen it out. That's a bad graph, but I showed you guys on Desmos last week. The third thing is the +7. Be careful with that one. Because a lot of kids, what do you think they write for that? 7, right. It's the opposite in there. 7 left. And how about the -5? There we go. You guys got those kind. You're good. We're going to nail those, right? The next page. Now it says to write an equation that reflects over the given axis. So what they want you to do is, without graphing it, to take whatever this graph would be and flip it over the x-axis. Watch what happens when you take just a single point. Like let's say that's at 1 over 2 up, and you flip it over the x-axis. It goes to it goes to 1 over 2 down. Does that make sense? So do you see how the y's go opposite when you fold it over? So what you do is you take the opposite of both of these. And here's how you're going to remember that, Rhea. Are you ready? Do you see how I took the opposite of 2 things? Think of the x as being like 2 negatives. So when it says x-axis, you take the opposite of both of them. Does that make sense, Leah? So if it was this, y equals 4x plus 10, and you reflect it over the x-axis, what are you going to write? Y equals -4x minus 10. Think of the 2 negatives, you negate both of them. Had that been a negative, it'd be +4x minus 10. You negate both of them. For the y-axis, right, I only see one of those negatives. Think of it as being 2 negatives and then just the 1. Watch what happens when you reflect over the y-axis. 1, 2 goes to -1, 2. The x's go opposite. So all you do is take the opposite of the x. All right, so this becomes y equals 3x plus 8. Shay, do you think you'll be able to remember that for the test? Had this one said x-axis, 2 negatives. So you would have made it 3x minus 8. You see the difference?
You put a -8.
That's because it said the y-axis. For the y-axis, you only take the opposite of the x term. So I'm going to put the practice one down here. Y equals -5x plus 2. If it says, Shay, to go over the x-axis, what will you write? Almost. 5x minus 2. If it says the y-axis, then what are you going to write? 5x plus 2. So for the x-axis, you take the opposite of both of them. Think of those as being two negative signs. For the y-axis, just the opposite of the first term. What do you think? Got it? We're nodding. All right. Moving right along here. Graph each. Give the vertex and the axis of symmetry. All right. Here we go. The vertex. By the way, this is going to be a v because it's the absolute value. This is going to be a v. It's an absolute value. Are there any more down here? I'm going to just make sure because sometimes they ask domain and range on these too. So we're going to add that to it just in case. All right. So to get the vertex, that's a point like this. Because it's normally at 0, 0, and this moves it 1 to the right and 3 down, there's my new vertex. But I think when I was doing this with Connor, I said it's whatever makes this 0. It's the opposite of what you would think in there, so take the opposite, and this is exactly what you would think. So there's your vertex. When I graph it, remember this number out front, Maria, is the slope. So because there's nothing there, I'm going to use a 1. I'm going to go up 1, over 1, up 1, over 1, up 1, back 1, up 1, back 1. Slope it out. I don't know how many points they tell you to use. 3 is probably good. Okay. Shay, do you get why I chose 1? Do you get why I chose to go up 1, over 1? And don't forget to put the arrows on the end. Leah, do you get why I chose to do up 1, over 1? It's whatever's in front here, and there's no number there. So that means there is a 1 times it. Now on this one, I'm going to be going up 3 over 1. So that lead number is the slope. The axis of symmetry is the splitter. It's this guy. And it's always x equals your x coordinate. What do you think? I'm going to add a question. What did we say for the domain of these last week? All reals all the time. Yep. And remember for the range, it's always about the y's. So I always say put the y's down. And then we're always living above this. This whole parabola is always above it. So put your above symbol greater than or equal to. And it's always above -3. You can see your y value right there. Should match that y value. What do you think? Are we getting it? So watch the next one. Vertex. Opposite of what you would think. Exactly what you would think. So what am I going to write for the vertex? 2, 4. Yep, I heard it. 2, 4. Excellent. I'm going to go put a dot there because I'm supposed to graph this anyway. Are you with me? I think you did this on Delta Math, right? Yeah. So then what's this one's slope? 3. What does that mean I'm going to do with my pencil? There you go. Up 3, over 1. Maybe do it a couple times. Up 3, back 1. Don't forget to put the arrows. The axis of symmetry goes right through the vertex. It's like your spinal column. Cuts it into 2 equal pieces. But it always goes through that x value. So you just write x equals 2. Connor, what's the domain? All reals all the time, right? X can be anything, but the range is controlled by the vertex. I'm always above it. So will I do a greater than or a less than? Greater than or equal to? What value? What are all the y's greater than or equal to? 4. Perfect. Now, had it been an upside down V, means it would have led with a negative, right? And we would have gone down 3 over 1, and then this would have been, less than or equal to. You see what I mean? The difference between those two, so good job. Moving right along. Then you had to graph linear inequalities. whenever you're graphing and you see these symbols, it means you're going to be shading. So if you're like, I never know when to shade or not, when it's a less than or greater than, it means above or below. So there's going to be some shading. So before you can graph the line, you need it. I'm going to put a less than or equal to on that guy. Is there a B? Is it down here? I've got A and C. That's kind of weird. So if I go over here, before I can graph the line, Rhea, I need to solve it for Y. Do you remember doing that last week? So how do I get rid of this right here? You do. You do the opposite. It's a positive 2x, so she's going to subtract it. Right, Connor? And I get the negative 4y less than 8 minus 2x, or you can do negative 2x plus 8. Leah, how do I get rid of this negative 4 right here? It's negative 4 times y. I will, and you got to remember, we worked on this last week. Do you remember when we divided by that negative, Leah? What did we say we had to do? Flip the sign. Thank you. And that's going to affect your shading, so you got to really watch that. So y will be greater than, and then this goes by negative 4, and then this goes by negative 4. A negative divided by a negative is a positive. Who's up next? Back to you, Shay. So which one of these is the y-intercept? Thank you. The negative 2. Perfect. So plot it. And Shay, if it has a slope of a half, what am I going to do with my pen? Perfect. Before you connect them, Connor, you got to be careful because there's going to be an easy point that's going to get lost by most kids. They're just going to go connect them. But remember, this guy means you're not going to do a solid line. You're going to do a dotted or dashed or whatever they told you to do. So watch that because, Rhea, that's an easy point to lose because you just get going and want to connect them. Next, how do you decide whether you shade above it or below it? Sometimes, that's actually with the absolute value ones when they're already solved for y. For the lines, you actually should go test a point. Do you remember what point you're supposed to test? 0, 0. So I'm going to go put a little dot right there. Go back to the original and plug in a 0. You get 0 minus 0, 0, less than 8. Is it true that 0 is less than 8? Yes. So you shade that side. So do you see how that was a less than, but I'm above it? So that only works for the absolute value ones because they're already solved for y. It's when Leah told me to change the sign, it made me flip my shading. So I would always test what point? 0, 0. So let's go to this guy. This is already solved for y. I love it, right? I'm going to go to negative 4 because that's my y-intercept. I think I'm at you, Rhea. Who's my slope?
Up to over 1.
Perfect. She said up to over 1, those of you at home. Right? And then will I connect with a solid or a dotted line?
Solid.
Solid, yeah, because I changed this because I wanted to make sure I had one of each. So just solid, don't forget the arrows. Then you're going to test 0, 0. So I'm going to go take that point. I'm going to ask myself, is 0 less than or equal to a negative 4? And that's not true. Right? So then, since this one was a no, where do I shade?
Down.
Down. Excellent. All right, you think you got that down? How are we doing? You feeling good? Hope so. Hey, keep it in your brain for 2 more days, though. That's the problem with this schedule, this alternating day thing. Now, when it says write a linear inequality for each graph, you have to now undo what we just did. So you're going to put a y. You're going to put a y. You need a y-intercept and a slope. Does that make sense, Rhea? Yep. So the y-intercept on this one, or the b, is a negative 2 right here. What's the slope? Well, you have to walk yourself to another point. It's going up 2 over,
3.
almost looks like that says 126, but it's a 3. Doesn't it look like it says 126? It's got to be a 3. So it's going up 2 over 3. So there's my 2/3 for the slope. So it's always y equals mx plus b. But there's shading, which means you need a less than or a greater than. Correct? See, we need a less than or a greater than, and we're below. And is that dotted or solid?
Solid.
That's solid, so I better do less than or equal to. You guys go try the next one. Undo that thing. You need to have your y, you need to have your mx plus b. You need to, from the graph, Leah, find your m, and from your graph, find the b. Remember, the b is where we hit the y-axis. And that one looks solid too. Keep in mind, if on your test it looks dotted, don't forget to not put the, again, these are just similar, but not exact representation. All right, I'm gonna go, because the big point ones are coming. I wanna make sure I get through all of them, mainly for the B group. So thank you, A group, for helping me, but you don't even really seem to need a whole lot of help. But we're gonna go take a peek. My M is my slope, right? Be careful because you go left to right. This is actually going down 3 over 1. So be careful that you did a negative. I see erasing going on. So be careful of that. You always look left to right. And here it was up 2 over 3. On here, left to right, it's down 3 over 1. My y-intercept is up here at 3. I'm going to take that off because there's shading, right? Shading indicates greater than or equal to, right? Or less than or equal to. All right. I know I went kind of fast through that one, but I really wanted to get to the absolute value inequality ones because these have a lot of points attached to them, okay? So the minute you see the absolute value bars, you're going to think that they kind of piece together like that. This is going to be a V. When you're done, Leah, you better get a V. Because this is a less than, you're going to get a V with some shading. Does that make sense? Now, Rhea, are you ready?
Yeah.
The first thing you need to graph it is to know where this vertex is. It comes from this and that. Where are you going to put your dot? 3 up. Yep.
And then to the right 4.
Yes. So I'm going to go right 1, 2, 3, 4. Up 1, 2, 3. That's going to be this dot. Okay? So I took care of those two things, the -4 and the +3. That's the left, right, up, down. What's the negative going to do to it? It's going to flip it. And remember, this -2 represents the slope. So from here, go down 2 over 1, down 2 over 1, back 1. It's symmetrical, right? So like that. Make a nice thing. And then somebody tell me why I would get a point off right now. You see it? I did it on purpose. Yes, it should be dotted line. So be careful. That's an easy one to miss. Because it wasn't less than or equal to, it's just less than. So I'm going to go make it dotted. And the last thing, Connor, is the shading. And now your answer to my last question. Because it's already solved for y and it says the y's are less, do you shade above or below? Yes. Be all this stuff in here. And I think we have time for you guys on that same grid. Is that the last one? There's another one. Oh, graphing these. Be careful with these. Because these are the ones that screw kids up. Are you ready? Do you remember what just the x equals makes? It's a vertical line. Yep. Thank you. Boom. X equals is vertical. Y equals, I always think of it as spelling yeah. Y equals is a horizontal line. Or you can just go put a bunch of -2's on your y, because it says the y is always -2. Or you can think it has a slope of 0, whatever you want. But be careful with the difference between those two. So for letter C, will it be horizontal or vertical? Horizontal. Now watch this. Shade. If this had said less than or equal to, that should trigger shading, right? And you have to go for where the y's are less than 4, so you shade under here. So Leah, do you get when you're going to be shading on your test? This stuff, no shading. This, shading. All right, so watch out for that. The next one up, y equals x.
Like a normal positive slope, so up 1.
Yeah, it's a slope of 1 and a y-intercept of 0, or it's where all the y's are equal to the x's at 1, 1, 2, 2, 3, 3, 4, 4. But Connie, you're totally right. It's going up 1. It's just like your boom. Whoops. Then having said that, Connor, do you know what y equals -x looks like? Yeah, you're going to do great. Yes, the opposite. And if I change that to less than or equal to, what do you have to know to do? Shade. Exactly. Awesome. Are there any more, or was that it? I want you to go back a page before I let you go, because I have you for like 1 more minute, 2 more minutes. I want you to try one of these big, because these are worth like 4 or 5 points for getting your vertex in the right spot. I want you to do y greater than or equal to, let's do 1/2 and do x plus 3, and then let's do -1. All right, you guys are going to tell me because we got to go pretty soon. Remember, the first thing you do is get its vertex down, right? Vertex will be at
3, -1.
almost -3. That's a super common mistake. It's the opposite of what you would think. So -3, -1. Boom, done. This is your slope. It's going to be going this way now because it's positive. So you're going up 1/2. Notice that compression, or how fat it's getting, because that's what the half does to it, right? I'm going to do solid because of the equal to. And it says greater. So I'm going to stay above. Boom! How'd you do? All right, we're done. Adios. If I were you guys, I'd do that one more time before when?
Wednesday.
Yes.